Hello, and today I'm going to show you a presentation and showing some examples of parametric equations. Now the topics we're going to cover today are shown with the graphs and the lines. So we're going to begin in steps lined out here. So how do we create a straight line motion? Basically we have t, which is subbed in for x and t. So time you sub in for x. So as you can see from time, you can see on the graph that we create a straight line with the basic formula x equals mx plus c. So y equals mx plus c, and you just sub in the x point for the y. So here we have 3t, which is 3 times time, and x is going to be carried by plus 5. So if you drag it up, you can see that the lines are drawn as time moves, because these are the formulas I'm following for the x and the y. Now, in the next example, this is called an oscillation, which covers from cosine, which is an angle which is going to represent t. So the cosine of t, now we have to use radians, which we'll explain a bit later about radians, but basically a computer needs to use radians to get the degree. So basically you just need to know that the t is, say, 30, that means 30 degrees converted into radians, which gives us our answer. Now as you can see from the x position, obviously on the graph you have to think of it, is this size, and it rotates back and forth as time goes on. And we'll look at speed and all that later. So y is permanently locked to 8, you'll get this oscillation because it doesn't alter. Now if you had it the other way, x would be going, it would go this way. Now go down to the next one. This is how we create a wave type motion. This is where you've got the y-axis is allowed to move, and along the x-axis we have the wave moving left to right. As you can see, that's the x-axis that way. And y is moving constantly with time, so it's drawing from here up, which I'll just prove with the graph. As you can see, we start lower and it waves back and forth. Now the circle is a sine and a cosine, which are just different positions of the waves combined together on the x and the y axis. And when they're combined together and you just take them as x and y instead of taking over time, because we subbed in time for these are just the basic ones, you can see that you have a circle there. Now when you move it round, you see the starting position of x is 0, y is 1. So our position is going to start on the circle from the top, moving round. And you can draw it, and the other directions there, but I'm going to get into that a little later in the video. For 2 sine and 2 cosine, this basically means that we have a radius of 2 in the up and the y. As you can see, it starts at 0 here and 2 here. So when you can see here is y, and this is the x rotation. So you can see that it's clearly like 2 waves that have gone between the points, but when they combine, they become a circle. And then 3t is speed. Basically, it means how many times within at normal speed it will take 360 seconds to go around, because 1 for each degree. So 3 times will complete in 120 seconds. So if I draw it just below 120 on the time here, you can see you nearly get the circle. That's 1 circle. And obviously there's 2 more there. So you can see them overlapping there a bit. Just to do with scaling. Now for sine and cosine, same thing. You can see the radius. And we have the same graph. Yep. We have x where we have plus 3 and minus 3. Now what this does is the initial position of the center point is 0, 0 for the circle. So assuming we're adding 3 to the x, and then we're taking, see, we have plus 3, and then down 3 for y, right in the center. 3 minus 3. 3 minus 3 for 0. And time is tied in. So when we look down here, we can see that this is the same kind of one. Even though the +1 plus is here and the -1 is here, it doesn't matter, it does not affect the calculation, so we end up with the same offset. We have a -1 on the x, as you can see, and 1 plus 2 sine is 1 up, so that you can see the centre matches there. So these are not to scale sometimes. Now we have a sine and a cosine. Now because cosine is going faster, it redraws faster, the wave is more rapid than in the x position. So by the time this would draw, we now get an ellipse type motion because the other one is completing quicker, but they must complete at the same speed, both of them, in order to create a circle. That's what happens when you have different speeds. One is completing twice as fast as the other. Now, okay, so in radius is controlled by the r in front of the sine or the cosine. The centre is defined by the position of the c here. That's added on or taken away to make it from our previous examples. The speed is controlled by whatever is in front of time, and the motion point starts based on the radian that's put in here, or by sine and cosine, and whichever one you put in, because one wave is 90 off the other, so obviously its starting point is different. And the direction is controlled obviously by the motion that's here. That's the way that it's going to go in a direction. If you negative it, it'll go the opposite way that a sine would normally go, and a cosine will go normally a different way. So in radians, 2 pi is 360 degrees or 0. From secondary school we'd only know degrees, so basically 3 pi over 2 is a pi and a half, so you get 270. 1 pi is 180 degrees, and half a pi is 90 degrees. So that shows us here. Now basically in the trigonometric identity you have opposite over hypotenuse and adjacent over the hypotenuse, and obviously if you take that identity, you've got sine to the power 2 and cosine to the power 2 is 1. So if we distributively remove subbing these into the equation, then you get this, and if you put it over, multiply everything by r squared, you remove the over r squared here, so you just get y squared plus x squared is r2 squared, because 1 by that is obviously just that. So that makes proof that that's how we get a circle. Now for our thing, we're going to create an object moves in a straight line from 2, 4, where t is 0 and the point 12, 24, 5 seconds later. If we set those up, we have our positions on our movements. It's going to move, the x is going to go up here, and the y is going to move by this much in the distance. Obviously, you divide this by the time that you want it to be at the completion point at, which is 2, and that's 5.6, so obviously that's the speed you're going to have to move to do it in that time. So we have our equation written out here, +2. And +4, no -4, because that's our initial beginning, we're not starting at 0, 0. So you have to add that into your equation. Right, okay, so when we draw that out, we get our line. Now for the second one that you saw was going to be a circle. An object is initially at 7, 2 and takes 120 seconds to complete a circular motion of radius 4 about a center point 3, 2. So if you look at that, the difference between that is obviously 4, between 3 and 7. That's on the x-axis, so it's going to go from position here to the right. And that's our starting point. And then it's going to move a circular motion. It doesn't say a direction, so we're free to use whichever one. But we're better off using the one that would go that direction, so we're better off starting with cosine, because it starts here, and it doesn't matter which direction it moves, because we already have our starting point. So if you have a look here, you can see that time 0 and time 120, that's obviously going to mean we need a speed of 3 to do it in that time. Radius is going to be 4, speed is going to be 3 obviously, because we found that out, cosine or sine. Now we know that x and y need to be in that position. P. Alright, so we basically just sub that into our sum. We have the radius goes here, the speed goes here, where we said in our function below for defining this parametric equation, and then the position is 3, so that goes in here. And obviously they have to be the same to maintain a circle, and the radius has to be the same to make a circle, and as you can see from our example, we have it complete. Thank you.